All right, so today we are talking about properties of quadrilaterals. You should have taken and finished your mini quiz. Everyone should have. You get a notes sheet, and then when you are done with that, you will get classwork and homework. Okay. On your quadrilaterals notes sheet, start on the back because we're going to start with all the definitions first, and then flip it to the front, and we'll go over every quadrilateral that there is. Okay, hopefully that mini quiz went well for you. We're going to start off our quadrilateral section with a bunch of definitions. So, in your notes, you should be filling in these blanks as we go. First, we're talking about congruent angles, and these are just angles that have the same measure. So, if I'm looking at an angle, that's select. If I'm looking at an angle like this, an angle like this, say they're both 30 degrees, okay, we can write that they are congruent, and we use this little symbol, an equals and a squiggly line above it for congruent. So they're just angles that have the same measure or degree. Congruent segments are similar. They're segments that have the same length. So again, we use that congruent symbol to describe congruent segments. Okay, those are just line segments that have the same length. Parallel means two or more lines that will never intersect. Okay, we can use two symbols like this, where those lines will never intersect, or we can use just straight up and down, two lines like that to mean parallel. Okay, they run side by side forever and ever, and they will never intersect or never touch. Perpendicular are two lines that intersect to form a 90-degree angle. Okay, so we show those like this. Diagonal means a segment that connects two non-consecutive vertices of a polygon. Okay, so if we're looking at this pentagon down here, a diagonal would be something like that, connecting those two vertices, or one like that, connecting those two, those two. And those two are all the diagonals, okay, that pentagon has. It's just a segment that connects two non-consecutive vertices of a polygon. Bisect. Bisect is a line, segment, or ray that divides something into two congruent parts. Okay, so if we bisect a line or a segment, we're bisecting that line into two congruent segments. Okay. Consecutive angles are angles that share a side but not a vertex. Okay, so if we're looking at this vertex, right, and this vertex, right, they share this side here, but they don't share a vertex. So this angle is consecutive with this angle. Okay. And last we have supplementary, and that's two angles whose measure have a sum of 180. Okay, so when I add those two angle measures together, I get 180 degrees, and that is supplementary. So today is all about quadrilaterals and properties of those quadrilaterals. So we're going to go through each type and list all their properties together. Okay, so let's start with our big, broad, overarching term of quadrilateral. All that means is we need four sides. Okay, it's a four-sided polygon. Okay, four-sided polygon. Okay, next is that the sum of their interior angles equals 360 degrees. Meaning if I add up this angle plus this angle plus this angle plus this angle, it'll get me 360 degrees total. Next we have a trapezoid. So trapezoids have exactly one pair of parallel opposite sides. And in this case, we're talking about their bases. Okay, so our top portion here is called a base, and our bottom is called a base. These other two sides are called legs of our trapezoid. Okay, so exactly one pair of parallel opposite sides. We're talking about our bases here, so we can mark them as parallel using those two distinguishing marks, or little arrowheads. Okay. Here we have a special type of trapezoid, and it's called a isosceles trapezoid. Isosceles trapezoids have congruent legs. Okay, so congruent legs, meaning we can mark this leg congruent to this leg. Okay. They also have congruent diagonals. Alright, so these diagonals across are congruent to each other. We also have congruent base angles, okay, meaning this base angle is congruent to this base angle, and this base angle is congruent to this base angle. Okay. We also have that their non-base angles are supplementary, so non-base angles are supplementary. Okay, and this also has all the properties of a regular trapezoid. So we still have our one pair of opposite parallel sides, and those happen to be our bases. Okay, so now we have what's called a kite. Kites have two pairs of consecutive congruent sides. Consecutive congruent sides. Okay, meaning the two lines that are in a row, like this side and this side, are consecutive and congruent. Same with our bottom pair, our other pair of consecutive congruent sides. Okay, also has one pair of congruent opposite angles. So clearly I'm not talking about this angle and this angle. Those are not congruent. Alright? What we're looking at are these opposite angles, and that they are the same in every kite. Okay? Or they're congruent in every kite. Okay, next we want to note that they're diagonals, okay, meaning these lines right here, okay, are perpendicular to each other. We also want to note that one of the diagonals, so one diagonal, bisects the other. Okay, only one is bisected. So again, I'm not looking at this short one and this long one, right? I'm looking at the two that are the same length. Okay, diagonals are perpendicular, right? And that one is bisected. Okay, so it makes two congruent parts. Next we have a parallelogram, and parallelograms have two pairs of opposite sides that are parallel. Okay, meaning we can then mark these sides as parallel using our parallel symbols. Okay, they need to be distinct, and that's the reason I'm putting two of them here and here, because that side is only parallel to that side, and one of them here, because this side is only parallel to this side. Okay, so it needs to be distinguishable. Next, we have that the opposite sides are congruent as well. Okay, so again, we can mark our sides. This side is congruent to this side is congruent to this side. Okay, so two pairs of opposite sides are parallel and opposite sides are congruent. We also have the opposite angles. So angles are congruent as well, okay? Meaning this angle is congruent with this angle, okay? And this angle is congruent with this angle. We have that the diagonals bisect each other. So diagonals bisect each other, meaning the diagonals cut the other ones in half. So this diagonal cuts this one directly in half, and vice versa. Okay, obviously not drawn to scale on here. And last we have that the consecutive angles are supplementary, okay? Meaning if I add this angle and this angle together, okay, we get 180 degrees. Same with any pair of consecutive angles inside a parallelogram. So here we have a rectangle. Rectangles have all the properties that parallelograms have, and they also have 4 right angles. Okay, so all of their angles are right or 90 degrees, and their diagonals are congruent. Okay, so this length is the same as this length. Now, rhombus or rhombi have the same properties as a parallelogram, plus they have 4 congruent sides, meaning all of their sides are the same length. Okay, 4 congruent ones. We also have that the diagonals are perpendicular to each other. So when the diagonals cross like this, they give you 90-degree angles all the way around. Okay. And last, the diagonals bisect, okay, cut in half, bisect the opposite angles. Okay, so this angle is cut in half, okay, by that diagonal. Same with this angle, cut in half, okay, by that, cut in half, okay, and cut in half. All right, our last shape